In the previous lecture, you created a SD card that contains a fresh copy of the Raspberry Pi operating system. In this lecture, you will boot up the Raspberry Pi for the first time using the fresh OS, and then you'll set it up. By setup, I mean that you will do things such as enable the SPI I2C and the UART communications interfaces. We'll also expand the file system, just optimize the memory use, and then check the built-in version of Python and the Python interpreter. Just make sure that all those things are set up before we start the development work following the beginning of the next section. So as you can see, I've got here my Raspberry Pi and the fresh SD card with a new OS in it. I'm going to insert it into the Raspberry Pi and then apply power. You can see that on the Raspberry Pi 02, there are two USB ports. The one that is closer to the edge on this side is the one where you connect the power to. So the Raspberry Pi is now on. I'll just give it a few moments for the boot process to finish, and then I'll be able to use SSH to connect to it. There's a couple of options. So you can see here with SSH, I'm using my macOS terminal window, or you can also use the Serial application or any other tool that allows you to connect to a device using SSH. I find that an application such as Serial, which is this one here, is very convenient, especially if you have a lot of devices that you want to connect to, either on your local network or externally, because you can create bookmarks and then very quickly just double click on one of the bookmarks and connect to your device, so you don't have to go to the command line and type in the entire command, which takes a little bit more time. Okay, so as you can see now, the green activity LED on the Raspberry Pi is settled. Means the boot up has finished. So I'm going to use my terminal window here instead of Serial. Just going to cancel a lot of that to connect to my Raspberry Pi for the first time. Just zoom in a little, make the text a little larger. All right, so the command is SSH. I'm using the Pi user, and I'm going to use the host name, which is rpiz2wb.local. And accept that, and my password, that's standard password. Hopefully I typed it correctly. Nope. Try again. Yes, second time lucky. Okay, so I'm now in my Raspberry Pi OS. The first thing that I want to do, as I said, is to enable the communications protocols. So I'm going to use sudo raspi config for this. So let's go to interface options, and SSH is already enabled. I will enable SPI, even though we're not really going to be using SPI for anything, but just in case I need it later on. Back to interface, we're definitely using the I2C interface. And one more for the serial port, we are definitely using the serial port. That's for the HC12 communications transceiver. So I've done SPI, I2C, and UART. The next thing that I want to do is to go into performance options, go into GPU memory, and release memory from the GPU back to the main system. So basically I decrease the GPU memory, the graphics processing unit memory, because I don't need graphics, down to the minimum 8 megabytes, so that's okay. And the last thing is to expand the file system so that the entire space on the SD card is available. So great. Next reboot, this process will complete and the file system will be enlarged. So click OK or hit OK, and then use a tab key to go down to the bottom, select and the finish button, hit enter, and do a reboot. So just wait for the reboot to continue. I'm just going to give it a couple of minutes. Just observing the green activity LED on the Raspberry Pi will give me a clue as to when the reboot process is complete. And then I'll use SSH again to log back into my Raspberry Pi. Okay, it looks stable now, so I think the reboot is finished. So let's go back into the Raspberry Pi, same SSH command. And we're good to go. So that's it for now with the Raspberry Pi side. We're going to start doing some work on this and experiments starting in the next section. But before we do that, we've got 2 more lectures in this section. In the next 2 lectures, I'll talk about the ESP32 board that I'll be using for the remote node.